All right, compressed air as an energy source. As you already know, I guess you should know that air is a substance which can be found in unlimited quantity practically everywhere on the planet. The atmospheric pressure, which is a gaseous mixture primarily made of two gases, the main gases, in which 78% of it is basically nitrogen, and 21% of it is oxygen, right? There is a small amount of volume which have traces of other gases like carbon dioxide, helium, argon, and other things. Okay. Furthermore, depending on the climatic conditions, air also contains a certain percentage of condensed water. That is, we call it humidity, right? So when dealing with compressed air, the humidity can be a problem. As we are talking about the cylinders, these cylinders are made of, maybe iron or any alloy. And in case of if there is a water present, there is a component of water present in the air. This water can, affect the pneumatic system. The reason is that it can create the rustiness in the alloy or in the steel or whatever it is made of. That rustiness can be a bit of problem. Once there is a rust, it can create leakages or it can create some porous surfaces on the, on the cylinder. The life of the cylinder gets affected because of that. And once there is a leakage in the pneumatic system, repairing it costs a lot. Okay. So these are the things related to, problems related to dealing with the compressed air. Okay, there are some other impurities like humidity, and we have other impurities like dust, or some other solid particles. Basically, before using a compressed air before channeling the compressed air into the system, this air basically needs to be filtered. Okay. So the basic prerequisite needed for the smooth operation of pneumatic system is compressed air that is both dry and so this filter needs to what it needs to do is to make the air dry and clean, dry and clean from dust and other solid particles. So whenever there is a pneumatic system working, the compressor, wherever the compressor is, it has certain filters attached to it. So those filters are basically, one of them is for filtering the humidity or water from it, and the other filters are like they are stopping some solid particles like dust or other solid particles. Okay. All right. Okay, the air that is compressed for the purpose of industrial application is referred to as a compressed air. Okay, and it is also termed as pressurized air So um, besides that, temperature and besides that, the temperature and the pressure is one of the most important state variables used in physics, right? And um, for defining pressure over here, pressure is defined by P, which is equals to force over area, right? So basically it is defined as a force which is distributed evenly in all direction over the surface area, right? Uh, the unit of force is Newton, and with it uh, we can call it is a Newton over meter square. This is the unit, and overall it is equals to sorry, pascals, and this is the unit of pressure. So basically, 1 pascal is equals to 1 per meter square. Okay. There are other uh, units of pressure as well, which include bar, millibar, and there are some other as well. Uh, I will be, mentioning them in the later class today. But the basic pressures that we'll be dealing in this class will be in pascals or in bars. Okay. Okay. I hope that you know how the compression and expansion of air occurs. Um, you must have studied Charles' law and Boyle's law, hopefully. So I'm not going into detail the concept of the compression and decompression. Okay. Now we directly go towards the pneumatics and electro-pneumatic controls. What are the advantages and not using these pneumatic systems? Okay. Uh, so compared to other drive technologies, electro-pneumatic systems demonstrate a series of advantages and disadvantages. One of them is the availability of the medium, like the availability of a medium. The medium that we are talking about over here is the air, okay, which is free of cost, and air is available for compression everywhere in a practically unlimited. Okay, so this is one of the advantages with using electro-pneumatic system. Uh, the property of we are going to discuss is the transportation. Okay, the compressed air can be easily transported with pipes, right? So we can basically use pipes to transport the air. Uh, uh, it can also be on a very long distance as well. And the main thing over here is that no return pipe is required in the system. You can basically release the air or excess air out in open air. So no need for the return pipe, no need to take the air back to the tank. So this is one of the advantages. The other property we have for electro-pneumatics is the storage. Okay, the compressed air can be stored in a container. Okay, so we can actually use a container to store the compressed air, and even it can be transported in bottles, or you can say the small containers as well. I think you must, if you have visited any hospital, you would have seen the compressed oxygen air, right? So basically, it is compressed air as well, but it is a filtered oxygen. So the storing uh, compressed air is not a big issue, no big problem. It can be stored in a container. And the property we are going to discuss is the temperature. The compressed air is insensitive to temperature fluctuations. Okay, and its use can be done under the most extreme conditions. Okay, so we are saying that the compressed air, it is insensitive to temperature fluctuation. The fluctuation, if there is a minimum fluctuation, then it is, insensitive. But if the fluctuation of temperature is very high, then there is a, so in general we can say that uh, insensitive to temperature fluctuations. Okay, and this kind of compressed air that we use in electro-pneumatics is explosion-proof uh, air. Okay, or you can say the compressed air can also be used in areas where there is a risk of explosion. Uh, there will be a small explosion, but it will not be a, harmful, or it will not be harmful in a way that it creates high risk of fire in an environment. Okay. So the places where there is a high risk of explosion, this type of gas or compressed gas can be used. All right. The other property is cleanliness. Uh, Sometimes it happens that the pipes, there is a leakage in the pipes. Okay. Usually, if the system is a hydraulic system, then if there is a leaking pipe, maintaining the cleanliness in the environment over there is very difficult. But if there is a leakage in the electro-pneumatic system, the leaking pipes, it doesn't create any problems of cleanliness. If there is a leaking pipes, hoses, or pneumatic elements, they do not cause any contamination due to the escaping of air. So this is an important plus point in areas where, such as like food or textile industry. Okay, and then there is speed. Okay, with compressed air is relatively high. It operates at very high speeds. It can be up to 2 meters per second, uh, which can be achieved with the pneumatic cylinders. Okay, the velocity can be 2 meters per second. The controllability The forces exerted by the pneumatic actuators and their speed can be continuously adjusted. Okay, so how it will be adjusted? It will be adjusted, you know, uh, with the help of valves. Okay, and it also has a a very good load capacity. The compressed air tools and actuators can be loaded up to standstill, and they can be extremely capable of handling heavy loads. Okay. Maybe I'll give you some examples of pneumatic systems. All right. Okay, here you can see one of the trainers of electro-pneumatic system. Uh, okay, if you are able to see on the right-hand side, the white column over here are the valves, and you can see the cylinders here. These are the small cylinders because this is a trainer. In this trainer, we have a small cylinders attached to it, and on the left-hand side, there is a panel for controlling them. So this panel consists of relays, switches, valve settings, sensors, actuators, and all of the things. Okay. If you want to see the whole system of pneumatic, uh, okay. Okay, this is what a pneumatic cylinder looks like. If you can see in this figure, this is basically a cylinder, and it is attached to a valve. Okay, the small part over here, the smaller part over here is basically a valve. This valve is responsible for channeling the air in which direction the air should flow. So we'll be discussing in the later classes how the pneumatic system will work and how the valves will be working. Okay, so basic thing, uh, what an inside uh, cylinder looks like. There is a basically there is a piston inside, and based on in which direction the air is flowing. Okay, so let's come to the point. We were talking about some advantages and disadvantages of pneumatic system, right? So these are some advantages which I mentioned before. Now let's go towards the disadvantages. Okay. The disadvantages can be, one of them can be preparation uh, of the compressed air. The compressed air requires basically good preparation. The dirt, damp must be kept out of the system, as otherwise the subjects this subjects the pneumatic elements to be undue depreciation. Okay, uh, which means that if there is a dirt coming, unfiltered air is coming towards the pipes, or It is going inside the cylinders, then it is going to create some friction inside it, and due to that friction, there might be some problems. The operation of the cylinders basically is going to affect because of these issues. Okay. The second is the compressibility. It is impossible to attain a uniform and constant piston speed using the compressed air. So this is one of the issues with the electropneumatics. Okay, maintaining uniformity with pressure is very difficult, because it happens sometimes that sometimes the pressure is decreased, and due to that the speed of the piston is also decreased, and due to some reason sometimes pressure is increased in the system, then the speed of the pneumatic will be increased. So there is a way out to maintain or to regulate the speed. It is done through a regulator. That regulator can be a manual regulator, and it can be, controlled as well. Okay. Uh, how can we control the regulation of the air? It is done by using the pressure sensors. All right. The other disadvantages is that the compressed air is okay. Okay. The compressed air is only economically viable up to a certain expenditure of force. Okay. The traditional operating pressure is normally around approximately around 7 bars. But attaining very high pressure, it is very difficult, and it can be very expensive to attain large pressures. Okay, another disadvantage can be the air exhaust that is generated causes relatively large noise. This problem can be mitigated to a large extent using the sound insulation. So this issue, you could have, uh, experienced it while traveling on the road. Uh, there are some pneumatic systems available in the truck as well, and once the pressure is released, you can hear the noise. Okay, it is so irritating. It is so large noise that it can, affect the driver passing by from the truck. So this air exhaust can be a little bit irritating because it creates a large noise and can be suppressed as well using the sound insulation techniques. The cost, the major problem in dealing with electropneumatics is the cost. The compressed air is a relatively expensive energy source. uh, However, these costs can be somewhat offset by a relatively low cost of the pneumatic components and their high performance. Okay. Uh, One problem with these electropneumatic systems is that once they start leaking, uh, finding out the leaks is sometimes difficult over there. Okay. So these leaks can be from the pipes, from the hoses, or from the cylinder itself. So what happens in the industry is what people do usually, or what an operator does that is that he regulates the pressure and maintains the pressure at the back end. They try to overcome the leakage by increasing the pressure at the back end, which can be very costly to the industry. in the upcoming, years, or once there is a maintenance, is big, if there is a maintenance over that system. So basically what happens is that when there is a small leakage, over the time that leakage becomes higher and higher and higher, and once there is a leakage from one end, if it is not fixed, then it can create some problem as well, because the moisture can get mixed with that air from that leakage. The dirt can go inside the system, so this can create many problems in the later days. Uh, Maintaining the pressure at the back end is very wrongful deed, but it is a practice done by it is a practice done usually by the workers at the industry. So basically, the maintaining these pneumatic systems, if it is not maintained on a correct time, then it can cost the industry very much. All right. Okay, let us discuss some of the differences between pneumatics and electro-pneumatic controls. Okay. The pneumatic and electro-pneumatic controls, both of them basically feature a pneumatic power component, which is comprised of uh, actuators, right? And in this case, in both cases, the actuators can be directional control valves. Okay. Uh, these valves are basically responsible for controlling the direction of air. By controlling the direction of air, I mean that these valves can uh, uh, decide that if the air has to go into the system or it needs to be released out of the system. Okay, this is what I mean by directional control valves. And how they are actuated? They are actuated basically electrically. Okay, electrically actuated. All right. Uh, and what are the working elements in these both systems? Is working elements. These working elements can be cylinders or can be pneumatic motors. Okay, and it can be optical displays as well. Okay, these are basically the power components. Okay, the other components like the signal control component, uh, which consists of signal inputs and processing elements, is designed differently in both systems. For a pneumatic control system, The control is basically achieved by the pneumatic components such as various types of valves, air distribution routers, and sequencers, etc. Right? For electro-pneumatic control system, the signal control element is designed with electrical components like electrical push buttons, switches, proximity switches, or you can say that later on that we'll be also studying the programmable logic controllers. Okay. Uh, I hope that you understand this. Let me write it. The pneumatic. The control is achieved by uh, pneumatic components such as various types of valves and some air distribution routers and sequencers, etc. All right. For electro-pneumatic, obviously for the electro-pneumatic, the valves are there, but these valves are basically controlled using some electrical devices like push buttons, okay, switches, uh, some proximity switches. These proximity switches, by them I mean that they can be, you know, we call them limit switches as well. These include limit switches as well. Also, uh, we use some relays to develop relay logic control that we are going to study, and PLC as well, the programming logic control. Okay. In both cases, the directional control valves constitute the link between the power control and signaling control elements. Okay. So I hope that you understand the point. All right. Uh, okay, let's talk about some signal elements which are present in electropneumatic systems. Uh, Mechanical signal elements includes switches and uh, these switches have the effect of supplying power to a load. For example, can say a solenoid valve. Okay. Do any of you know about something about solenoid valves?
Yeah, I think I have one on
Okay, you have worked on it before?
we purchased for a project project for or was a gas project.
All right. Okay, okay, I understand. All right, we will be discussing in the later classes about the solenoid valves. Uh, what is their, uh, theory behind it and how they work. So basically, within the
Okay.
circuit, or yeah, okay. All right. So we are basically talking about the signal elements, though. So the solenoid valves can be one, and there are basically three types of switches which can be distinguished in this kind of electro-pneumatic system. Okay, one of them is momentary momentary contact switches. Okay, okay. This kind of switch is basically selected in a switch setting where it is maintained only as long as switch is being actuated. Okay, it is used in such applications where the switch setting is maintained only as long as the switch is being activated. For example, a doorbell. A doorbell, uh, it has a a switch outside your house. Once you press it, the doorbell it rings until you maintain uh, the state, right? You maintain the force over the switch. Once you release it, it switches off. So this kind of switch is basically known as the momentary contact switch. The second type of switch is basically known as the latching switches. Okay, the momentary, as I told you, that it is on until the switch is pressed, and once the switch is released, the output is switched off. The latching switch, you can think of it that the possible switch setting which are latched mechanically so that one switch setting is maintained until the switch is reactivated in new setting. Okay. Simple example of it that in your house uh, there must be switches installed to switch on your lights or fans, right? So once you press them, they are basically latched, and your fan or light is running until and unless you press it again, okay? Or you switch it off or use make that contact in other direction. So I hope you understand the concept of latching switches.
Yes,
Okay,
completely.
clear, right? So I'll just write over here for your example that switch is installed in your living room. The third type of switch, we call them limit switches. Okay, these are basically momentary contact limit switches. It is basically a particular variation of the push button switch. I hope you know how push button works. Yeah, a simple push button it is like this. When you press it, it turns on, and when you depress it, it turns off. The limit switch working is similar, but it has a slight physical variation. Okay, physical variation in a sense that it is something. Let me build one. There is a switch over here at the top. Okay, there is a bar connected to it, and there are some contacts coming out of it. One is uh, common, the other one is normally close, and there is another one normally open. So the common is basically connected to normally close. Okay, once this switch is pressed by pressing this bar, you can uh, connect it as a sensor. You can think of it as a sensor. When anything touches this bar will press the switch, and once the switch is pressed, this bar, which is the common which is connected to normally closed, will move towards normally open. Okay, and once it is depressed, again the bar will be going back from normally open to normally closed to its normal position. Okay, this is what a limit switch is.
Sir, for this
Yeah.
limit switch,
Mm-hmm.
is it like a button connected to the plate, similar to the mechanical sensor with the electric teapot for tea when you press the button to be on, when
Mm-hmm.
temperature rise to 100 and then the depress,
Yeah, it is
or
something
no?
similar, but in order to turn it on, a physical contact is required.
In order to turn it on.
Yeah, in order to turn it on, a physical contact is required.
Oh,
Okay, you can think of it like that. If there is one conveyor belt uh, where so many bottles are coming in, uh,
okay.
you can think of it as a water filling plant, and the bottles are coming on a conveyor belt, and this switch is placed in a certain position where the belt needs to stop, and the bottle should be filled by the nozzle. Okay, so when the bottle
Mm-hmm.
touches this limit switch, the conveyor belt will be switched off, and the nozzle will be switched on for some time to fill up the bottle. So in such applications, you can use limit switch as a sensor.
Okay.
Understand?
Yes.
Okay. We will be, later on working on it. There are some scenarios uh, which include the use of limit switches as well. Okay. Um, uh, in nowadays, basically the limit switches are being replaced by proximity sensors. The proximity sensors are basically they sense any type of object. Most of the time, they detect the metals. So basically, if there is on assembly line, there is a metallic part going on, it is moving. Whenever there is a metallic part detected, some action is due on the system, right? So basically, uh, nowadays, limit switches are being replaced by the proximity sensors. So both can be used. Using the limit switch is the cheapest one, you can say. Uh, it is more economical, but using a proximity sensor can cost a lot. Okay. Uh, these signal elements basically are the mechanical signal elements that we were talking about. Okay. Okay. Moreover, Uh, let's talk about these momentary contact switches first, and what is the symbolic representation of it when we are using them, right? Uh, for an electrical diagram, we will be developing an electrical diagram for our electro-pneumatic system. We will be using the momentary contact switch in such a way. Okay. And okay, this is something like this. So this is basically the symbolic representation of a normally open momentary contact switch. Okay, or we can say this is an NO. Sorry, I cannot hear you.
Oh, no.
Okay, you understood? Okay. Uh, so this is basically the normally open switch. You can it is uh, in other terms also called as a push button. So when basically you are making a electrical diagram for electro-pneumatic system, you will be using uh, this symbolic representation while making a push button. Okay, so it is basically a normally open switch. Once you press it, you can say that if this is pin number 3 and pin number 4, once you press it, pin number 3 is connected to 4, and once you depress it, they are disconnected. Okay. Uh, this momentary switch also comes in normally closed condition as well, and the symbolic representation is something like this. Okay. So this is how it is symbolically represented. This is a normally closed momentary contact switch, or you can call it MC. So in normal condition, pin number 1 and pin number 2, these two are connected to each other. Once you press the switch, the path that is connected from 1 to 2 is disconnected. Okay, once you again depress the switch, then again pin number 1 and pin number 2 will be connected together. Okay, so any problem until now?
Can you repeat the second one?
Uh,
Normally
I-
closed.
I'm unable to hear you properly. Can you repeat?
Can you hear me now?
Yeah, I can hear you now.
I said, can you please repeat the second one, the one normally closed?
Okay, sure. For the normally close, there are two lines, 1 and 2. So basically, these two contact points are in connection normally. Okay, in normal condition, they are connected to each other. But once I press this button, uh, the normally closed contact is basically broken. So it becomes normally open. Okay. So now, once I press
Yeah.
it, pin number one and pin number two are there, they are not connected to each other anymore. So if I depress it again, I mean that I leave the button, I leave the switch, then this switch is going to come back to its original position, that is the normally closed one. So pin number one, pin number two, they connect to each other. Okay. So this is basically, you can say the this one over here is basically the inversion of normally open. Okay, you can think of it like that.
Yeah. Okay.
All right. Okay. There is another type of switch, uh, a sort of like a momentary switch, but it is a kind of a latching switch as well. Uh, we call it uh, changeover contact switch. Okay, this changeover contact switch is like uh, let me draw it, then you'll be able to understand it in a better way. It has basically both the normally closed and normally open contacts. Okay, so this is your pin number two, pin number four, and this is your pin number one. Okay, this is actually a changeover contact. So this is your common point. This is your normally close, and pin number four is basically your normally open. So in your logic diagram, if you want to use a normally closed contact, you can use pin number two. If you want to use a normally open contact of the switch, you can use pin number four. Okay. So in this kind of switch, you can basically get normally open and normally close as well, any of them. So this is basically known as a changeover contact switch. Okay. Um, this is a prayer time over here. Maybe we can get a break for 2 to 3 minutes until the Adhan gets over. So just give me 2 minutes until
Okay.
Azan is over.
Okay, sir.
Okay. All right, we were talking about the changeover contact. This is also a sort of push button. In normal condition, pin number 1 is connected to pin number 2. This is actually a normally closed one. And when you press it, this switch, that the bar connected to common is basically shifted towards the open contact. That means connected to pin number 4. Okay, so once you depress it, that will come back to its normal position, that is pin number 2. So this is actually a changeover switch, right? Then we have call them latching switches, right? So in contrast to momentary contact switch, in a latching, the switch setting is assumed is also maintained after release. Like this type of switch can be designed with NO, NC, or changeover contactors. You can it is something like let me make a representation of it. It is a simple switch, but this one actually latches. Okay, once you press it, it will the pin number 3 and pin number 4 will be connected to each other. Once you take your hand away, still pin number 3 and pin number 4 will be connected. So in order to depress it, you will have to press it again. Okay, so this kind of switch is known as latching switch. Understand? So this is basically a no, normally open. Similarly, there will be a normally closed latching switches. Okay, for normally closed latching switch, we have a similar type switch, but in a different way. So this is basically an NC latching switch in which pin number 1 and 2 are connected to each other in normal condition. But once you press it, pin number 2 will be disconnected. But when you take your hand away, this point will remain disconnected until and unless you press it again. Okay, so how a latching switch is or these symbols will be used when you are using the latching switches in your logic circuits. Okay, so in contrast, for latching switches as well, there is a changeover contact representation as well. So it is similar. There will be pin number 1, pin number 2, pin number 4, and this latching will be the push button will be connected to number 2. Oh, sorry, pin number 1. Okay, so in order to change the contact from pin number 2 to pin number 4, a physical contact is required. Once you press it, the bar will move to pin number 4, that is the normally open contact. All right, and when you depress it, still this bar will be connected to normally open. In order to bring it back, you need to push it again. So then if you push it again, it will come back to its normally closed position. Okay, so the changeover switch is also possible in latching switches as well, right? Okay, Then we also discussed about the limit switches, how we are going to represent limit switches in our systems or schematically. Okay, the schematical representation of a limit switch is like this. Okay, so this is basically normally open limit switch, and if it has a normally closed contact, if you want to use a normally closed contact in the circuitry, then this will be the representation. Okay, so this is pin number 1, pin number 2. So if there is any limit switch in your control diagram, then and if it is connected in a normally open way, then you will be using this type of switch, or if your logic diagram contains normally close contact of the limit switch, then this diagram is required, or this schematic symbol will be used. Okay. Let me show you some of the examples of switches and push buttons that will be used in the electro-pneumatic systems. So this is the limit switch. Okay, this is what I made before as well. In this kind of limit switch has 3 pins, right? Common, normally close, or normally open. So the bar is connected to normally close. If you want to use a normally close, you will be using the second picture, and if it is connected in a normally open way, then you'll be using the first one, right? So there are many types of limit switches. You can see this one. Okay, this one is also similar but has a wheel on top, right? So when we are covering uh, the symbolic representations later on with for the limitics, then we will come to know about it. All right. Then afterwards, after the limit switches, we have relays and contactors. We already had some idea about the relays and contactors and how to use them. There is actually very little difference between relays and contactors, but usually the contactors are used as a switch in a switchgear system when you are dealing with very high amperes. Okay, for the relays are not used in such an environment where very high currents are required. Uh, let's say that a relay can be used in an environment where maximum amount of current of 20 amperes or 10 amperes is required. Usually it is 10, or maximum it can be 20. But the contactors, talking about contactors, they can bear up to 32 to 50 amperes. They can go more as well, depending on the size. Okay, and the functionality of both relays and contactor is same. There is a coil inside it. Once there is a coil energized, there are some normally open and normally closed switches. Uh, uh, they turn on and turn off. Okay, so the basic concept of relays and contactors is same, that is electromagnetism. Okay, We have already learned about contactors, their working, and we have already, worked on some scenarios as well. We uh, studied or we learned about running an induction motor using the contactor, phase changeover as well. With the relays in the first few classes, we discussed about how latching can be achieved using a relay. We learned about that as well. So we learned about both of them basically, right? But in, uh, you know, for electro-pneumatics symbolic representation, for the relays or for the contactors, we will be using uh, this symbol. Okay, so basically, right now, if you are able to see the screen, uh, I have designed a contactor over here or a relay. Uh, in this electro-pneumatics, we will consider relays and contactor equal. Okay, so we will have the same representation for both of them. So it doesn't matter if a contactor is used or a relay is used. If this kind of symbol is present over there, it is either a relay or it is either a contactor. It's the same thing. Okay, we will consider it as the same thing. So this over here, a little box here, a rectangle one where A1 and A2 is described. This is basically a coil of the relay. Okay, and there are certain switches over here. These switches are basically the output switches. Okay, so we can call this type of relay K1. All the relays and contactors used in electro-pneumatics, they are need to be represented with K. K will define the relay. The term K will be defining relay. Okay. So if there is another contactor, there are three contactors over there. So you will be naming them K1, K2, and K3, right? So K will represent the controlling part. That means the contactor or the relay. And the output switches over here, these three switches, they will be used to derive any output. Let's say a valve, okay, or they can be used for, sorry, okay, I was talking about these switches. These switches can be used for two purposes. One is uh, deriving any output from it, or they can be also used uh, for the control. You can say that they can be used for as a uh, using them for the control circuit. Okay, once we start using them, then you will know what I mean by this. Okay. All right. Okay. Okay, let me develop an example circuit diagram. Then you will know how to represent things in a circuit. Okay. So in a control diagram, always there are two lines. One line, we call it plus 24-volt line, and the other line is basically 0-volt line or a ground line. So in between these two lines, we will develop our circuit diagram, or you can say a logic circuit or logic diagram. Okay. Let me develop a small circuit diagram where I will attach a relay and a switch. So once I operate a switch, the relay will be switched on, and I will attach a lamp with it. So once the relay is switched on, uh, the lamp is switched on, and if the switch is depressed, and the lamp will be switched off. So let me develop a circuit diagram for it. So let's suppose this is our network 1. So I have a switch over here, which is actually connected to a relay. Okay, and we say this is K1. This is A1 point of the relay. The A2 point of the relay goes to the ground. Okay, always make sure that your relay is connected, or you can say that the point A2 of the relay or the contactor is connected to the ground line. Okay, always make sure that uh, the output relay, you can say that this relay is always connected to the ground. You cannot place any of the switches at A2. Okay, any switches or any logic diagram has to be in this area before the relay is attached. Okay, the end of the network needs to be with the relay. Understand? Okay.
Yes.
All right. So this switch over here, I name it as S1. This is a momentary contact switch. I'll press it, the relay will operate. I'll depress it, the relay will not operate. So according to the diagram or symbolic representation, okay, this is the switch of the relay, right? So I'll connect a lamp with it. Let me connect a lamp, and I represent it by P. Okay. So what will be happening over here? Once I press S1, the current will be passing from here towards the ground from the relay, right? So it will excite the coil. Once the coil is excited, this normally switch over here of K1 will switch on, right? It will be connected to this point. So now the current coming from the network 2 over here, it will be going towards the ground. The path will be available for the current to flow towards the ground, right? Once this happens, this lamp over here will switch on. Or you can say there is an LED connected over here that will start to glow, right? So once I depress this switch 1, the path of the current is broken. Once it is broken, the K1 over here will be demagnetized. So once it happens, this switch will come back to its normal position. So it will disconnect the current's path. Once it happens, the lamp will be switched off. Okay, the lamp will be switched off.
Sir?
Understand? Yeah.
Yes, but what is the rule of relay here? Is it like a safety or what? Because without using it, we still can switch on and switch off the lamp from S1.
Yeah. Basically, I'm making just a basics over here. Uh, we will
Yeah.
be, there will be a lamp later on as well, but there will be some logic diagram, logic circuit before it. There will be certain logic circuit. So
Uh, yes, I have
understand.
used this relays. I used the 8 relays. In my
Mhm.
project, there were like about 8 components: lights, fans, sensors. For each of
Okay.
them, we used a relay, and I didn't really get it why.
Okay. All right. The reason can be like I don't know what was the project that you developed. Uh, in order to run the light or a fan or any output, uh, that output may be connected to 220 volts, right? So at the input side or before the relay, you are working on 5 volts, but at the output side, you are working on 220 volts. So this is what relay does. It provides an isolation between an input and output circuit. Okay, so basically we are
Mhm.
translating low input voltage towards, we are going towards the higher input, higher output voltage. This is what the relay does. What This is what the advantage of using a relay. Okay,
Okay.
yeah. So, over here in this course, basically, we will not be discussing that we are deriving 220 volt uh, output from it, or we are deriving any bulb from it or actuator from it. No, no. We will be basically working on the logic diagrams over here. Okay. I will be starting with AND logic, OR logic, and then we will be going towards some complex logic circuits that will be implemented on electropneumatics. So just bear with me a little bit uh, until we come over there. Okay. So right now we are just sticking to the basics that how to develop electrical control diagram for electropneumatics. Understand?
Yes, sir.
Okay. Uh, so this is one of the ways for developing electrical diagram. The second way of defining this circuit can be, let me develop it, this plus 24 volt line, and this is a 0 volt line, right? And again, we have a switch S1, and we have one over here connected to ground, and in a network 2, or maybe in the later circuit network 3 or network 4, if I want to use the normally open contact of K1, I can use it. Okay, so how I'm going to use it? I'm going to use it like this. So this is P, this is K1 over here, and that's it. So these two circuits are basically same. Okay, uh, only the difference over here is the representation of the switch K1 over here, right? On the left hand side, if you see the circuit diagram, I have used the whole relay representation, but on the diagram on the right hand side, you can see that I haven't used a proper symbolic representation of the relay. You can see that there is a coil of K1, but the switch of K1 is being used on other network, but it has no relationship, like, you know, there is a relationship, but I haven't used a proper representation over here. This was the symbolic representation of a relay, right? But over here on the right hand side, I have used a switch in some other network. So this can also be done in electro-pneumatic diagrams. Electrical control diagram of electro-pneumatics. Okay, understand? So is there any confusion between the two diagrams?
So the one to the right, K1
Yeah.
switch,
Mm-hmm.
you just represented that way. It's in reality, it is connected to K1 coil.
Yeah, it is connected to
Okay.
K1 coil.
Okay.
Okay. Yeah, it is
Uh,
similar like this. There is a coil, A1 and A2, and there is a normally open contact. So there are many normally open contacts in a relay. So I'm just using one of them over here. Okay. Maybe in the later circuit, I have to use another K1 switch in order to operate another lamp. Okay, P2. So this is basically I'm using another switch over here, second switch. So there can be third one, there can be fourth one, fifth one also as well. Depends. Okay.
okay.
All right. Okay. We talked about relays until now. Let's talk about some other types of relays as well. And these relays are called time delay relays. Okay. There are two types of time delay relays. One is known as uh, pickup delete, and the other one is known as the dropout or release. These are the two types. Okay. Okay. Well, what happens in a pickup delay relays or dropout relay, uh, time delay relays? What is the difference between them? The difference between them is that okay, one more thing is that the pickup time delay relays are also known as on delay timer, and the dropout time delay relays are also known as off delay timers. Okay, so these two are basically timing relays. They are related to time, and what happens is that Once the coil is activated in a pickup delay timer, once the coil is activated, the timer is turned on, but the output is not turned on. It will be turned on after a certain time. Okay, so let me give you an example. Once the coil is excited, the normally close normally open and common point. Okay, this bar over here connected to normally close will not connect to normally open. It will connect to normally open after a certain time period. Okay, so this is what we call on delay timer or a pickup delay timer. All right. Uh, Regarding the dropout, release, or off delay timer, it is something like that. It works like that. Once the coil is activated, the bar moves from normally closed to normally open. But after a certain time period, this bar goes back to normally closed. Okay, so this is an off delay timer. Okay, understand? All right.
Yeah.
The symbolic representation of it is something like this. Let me give you certain. Let me give you an example of it so you can understand it better. So we have a switch S1 connected to a relay, but the representation of it is little different. For a pickup delay, we attach a cross to it, which represents a time delay before switching. Okay, and after this time delay, it will switch on. And just give one. Okay, so this is how we can represent a time delayed or on delay timer in our circuits. So if we want like P1 to be on after a certain time, once S1 is pressed, then we can use an on delay timer. And how to use an on delay timer? We use it like this. Okay, and its normally open switch can be connected to derive any of the output. That can be anything, a bulb or something like that. In our case right now, it is a lamp. Right, so what happens in the circuit once I press S1, the coil will be activated, K1 will be activated, but this switch over here will not turn on. Okay, this switch will turn on, let's say, if I set the timer for 5 seconds. So this switch over here, K1, will turn on after 5 seconds. And this lamp over here will turn on after 5 seconds. Okay, so is there any confusion over here? Yes or no?
No.
All right. Okay. So in reality, or in real time, how you are going to set the time of this sort of relay, this kind of relay, there is basically a knob available for the timer to set. Okay, or you can say that there is a potentiometer. The potentiometer or a variable resistor is available for you to set the time. Okay, so this is how you set the time for any of the timer relays. Understand?
Excuse me, sir.
Yeah.
When this class gonna be finished?
I'm just finishing in 2 or 3 minutes.
Oh, okay. Thank you, sir.
All right. Okay. Regarding the dropout relay timer relay, let me make the symbol for it, and maybe you can imagine how it will be used in a circuit diagram. Okay. An off delay timer. The symbolic representation is like this. We have a coil A1 and A2, but instead of cross, this part is basically filled. So it represents an off delay timer. So in this time period over here, the relay will be turned on, uh, but the switch will be turned off after a certain time. Okay, so this is basically off delay timer. And how to use them? Just replace A1 over here, that is done on delay timer over here with an off delay, and that's it. Okay. I hope that you have already understood the concept of using relays and switches. For tomorrow we will be working on some logic diagrams, some logic circuits, and we'll see that how we can control any output from it. Okay, how we can develop some logic diagrams and derive some output from them. So I hope that you understood the whole concept
Okay.
of today's lecture. I think that's it for today. So hope to see you tomorrow then. All right.
Okay. See you, sir.
Thank you very much.
Bye-bye.